Welcome to my channel. This time, I will be showing you solutions on the problems about leveling methods under surveying. But before that, please subscribe and don't forget to click the notification bell after you watch this video. This time, we will be solving a specific problem under levels over different routes. Here is the problem. Lines of levels to establish the elevation of point X are run over 4 different routes. The observed elevations of the point with probable errors are given below. Determine the most probable value of elevations of the point. You can see in our problem the values that are given. We have the 4 lines, with corresponding observed elevation, and probable error. The first thing that we need to do is to solve for the weights on our 4 different lines. But before that, you have to take note that the weight is inversely proportional to the square of the probable error. Now, you can see in our 4th column the values of the solved errors for our 4 lines. If you are wondering how did I get that, I would like you to pick up your calculator and follow these steps. First, set your calculator to radian mode. To do that, click Shift, then Mode. You can see number 4, which states rad. Then just click it. You can see in the upper right of your calculator the symbol R. It means it's already in radian. Next, click Shift, and then press Mode. After that, press down, then click the number 4, which states the stat. You can see the question frequency. Just click 1 or the on. Finally, click Mode, press 3, then press 1. You can see in your calculator the tabular format of X and the frequency. Now just input the values. I will show you how I did it. After getting the values of our probable error, we divide all with the value of the first line of 3.6 times 10 raised to negative 5 to come up with the value of our final probable error. In here, I will show you the solution how it is done. We begin with our first line. We divide the values and we have a value of 1. Next, for our second line, which has an answer of 4. Followed by the third line which has an answer of 9. Finally, our 4th line which has an answer of 16. After determining the values for our probable error, we have to be reminded again that this values of weight is inversely proportional to the square of the observed elevation. This relationship is applicable with all the 4 lines, that is why from weight 1, and its corresponding error, is the same, until the 4th line. The next step is to solve now for the value of our weight by substituting the values of our probable error to its corresponding weight. We have, weight 1 multiplied to probable error 1 is equal to weight 2, multiplied to probable error of 4, so on so forth. Now, to solve for the weight, we let weight 1, equal to 1, to solve the values for our weights 2, 3 and 4. Now we have, weight 1 is equal to 1. A while ago, we said the weight 1 and probable error 1 is the same as the second weight and second probable weight until the 4th line. So we have for second weight of 1 which is the weight 1, is equal to weight 2 multiplied to the probable error of 4. We obtain weight 2, we divide both sides with 4 giving us a value of 1/4, for weight 2. Just do the same process until the fourth line. So we have a value of our third weight to be 1 all over 9, and in our weight 4 of 1 all over 16. Finally, we must have to get the sum of the weights. We just simply add all of them. And we have 1, which is our value for weight 1, added to 1/4, added to 1 all over 9, added to 1 all over 16. We simply solve and the answer is 205 all over 144. That is now the value for our total weight. We will use this later on, as we get our final answer. Our second step is to solve for the value of our weighted observations. To solve for that, we will use the formula, weighted observation is equal to the product of the observed elevation multiplied to the weight that we solved a while ago. Now, we begin solving the weighted observation for our first line. The value for our observed elevation is given in the table, so we simply substitute the values. We now have weighted observation line 1 is equal to 219.832 multiplied to 1. The answer is 219.832. Second, for our second line of 219.930 multiplied to 1/4, and the answer is 54.9825. Next, for our third line, we have 219.701 times 1 all over 9, the answer is 24.411. Finally, for our fourth line, we have 220.021 multiplied to 1 all over 16. The answer is 13.751. After getting all the values for our weighted observation for our 4 lines, we get the summation of all. And we have 219.832, added to 54.9825, added to 24.411, added to 13.751. We simply solve and the total of our weighted observation is equal to 312.977 meters. Our final step is to solve for the value of our most probable value. We know that most probable value is just the same as our weighted mean. Now, to solve for most probable value or the weighted mean, we simply use the formula, summation of our weighted observation all over the summation of the weights. A while ago, we already solved the values of each of this. So what we need is to simply use direct substitution. We now have 312.977 meters all over 205 divided by 144. We simply solve, and the answer for our most probable value is 219.847 meter. That is now the solution for our problem. If you wish to see more tutorials with regards to surveying, you can visit in the description box. Please do not forget to subscribe before you exit.